The two most successful frameworks in the history of physics, quantum mechanics and general relativity, remain incompatible after a century of effort. This impasse exists because theoretical physics has substituted physical mechanism for mathematical formalism as the ground truth of reality. We can trace this error back to a misunderstanding of Emmy Noether's 1918 theorem. Noether proved a one-to-one correspondence. If a physical conservation law exists, a mathematical symmetry describes it. Modern physics inverted this causal arrow. We began treating abstract mathematical symmetries as the physical causes of conservation laws, rather than the descriptions of them. The founders of relativity recognized this dangerous shift. Albert Einstein himself expressed profound unease as abstract formalisms began replacing physical intuition, noting, "Since the mathematicians have invaded the theory of relativity, I do not understand it myself anymore." The point of no return occurred in 1939. Eugene Wigner published a paper classifying particles as irreducible mathematical representations of the Poincare group. The mathematics no longer described the particle. The mathematics was declared to be the particle. Physical ontology was formally replaced by mathematical taxonomy. Treating mathematics as prescriptive rather than descriptive removed all physical constraints from our theories. Theoretical physics entered an infinite landscape of mathematical possibilities, lacking any physical filter to determine which of the thousands of valid mathematical structures actually exists in nature. By allowing the mathematical map to dictate the physical territory, we constructed a century of artificial paradoxes. We obscured the actual mechanical universe beneath layers of elegant but ungrounded formalism. The ultimate victim of this mathematical inversion is Bell's theorem. For decades, the consensus in physics has been that experimental violations of Bell's inequalities definitively prove the death of local realism, forcing us to accept spooky action at a distance. This conclusion rests on a hidden, unexamined assumption embedded directly in Bell's algebraic model. Bell formulated quantum measurement as a passive noun, a simple, instantaneous readout of a pre-existing property carried by a discrete, bullet-like particle. One field theory corrects this category error. Measurement is not a passive revelation of a property. Measurement is an active dynamical verb. It is a physical interaction that modifies the state of the system it touches. We define this interaction as a quantum energy resonant process, or QERP. QERP is the physical reality of detection. An extended, continuous electromagnetic field interacts with a material boundary, depositing energy until it triggers a localized mechanical threshold response. When we apply the actual physical mechanics of continuous fields and threshold detectors to a loophole-free Bell test, the mathematical constraints of Bell's theorem completely dissolve. To understand why Bell's constraints dissolve, we have to isolate exactly what the theorem tests. Bell's central premise is local causality, the idea that an outcome at one detector depends only on the local settings and a local hidden variable, isolated from anything happening at a distant detector. The literature defending Bell's conclusions relies on a massive terminology trap. Physicists routinely conflate physical separation with mathematical factorization. These are two completely different concepts. Physical separation is an ontological claim about the territory. It states that two detector systems share no ongoing physical connection or signaling channel during the exact moment of measurement. This equation shows mathematical factorization. It is a strict statistical claim about the map. It asserts that the joint probability of two measurement outcomes must equal the direct product of their independent marginal probabilities. The logical gap between the two is vast. Two systems can be completely physically separate, yet still produce non-factorizable data distributions. This happens automatically if they share a common causal history, or if they are both interacting with an extended, correlated continuous field. Bell's theorem only constrains mathematical factorizability. Declaring that nature lacks local realism based on a Bell violation is an epistemological overreach. The data only proves that factorizability fails. We can prove this by auditing the hardware of the Justina 2015 experiment, widely considered the definitive, loophole-free Bell test that earned the 2022 Nobel Prize. The Justina setup relies heavily on specific optoelectronic detection pipelines. specifically utilizing superconducting nanowire single photon detectors, or SNSPDs. An SNSPD is a highly sensitive circuit cooled to near absolute zero, designed to register microscopic optical energy. This diagram shows the physical reality of an SNSPD. It's not a binary net, but a leaky integrate and fire threshold device. As the continuous field arrives, the nanowire gathers energy to overcome its thermal barrier. Only when breached is a voltage pulse generated. A detector click is not the instant a discrete object arrives. It is the delayed endpoint of a physical accumulation process, dictated entirely by the wave's intensity and the detector's local physical environment. Bell's model treats the polarizer dial as a simple mathematical label, but what physically happens to the continuous wave when rotated? As this animation demonstrates, the first physical effect is the geometric cross-section. A physical polarizing filter presents a completely different effective coupling area to the continuous wave depending on its orientation. This leads to the second effect, spatial sampling. By turning the dial, we sample different regions of the extended field. Because geometric coupling changes, the total energy delivered to the active SNSPD element varies, causing a physical intensity drop at the detector. This intensity drop shifts the detector's boundary conditions and threshold dynamics, ultimately triggering effect 6, time walk. Time walk is an electronic phenomenon where lower intensity signals take longer to reach a trigger threshold, systematically delaying the timestamp assigned to the event. Rotating a polarizer doesn't just change the question asked, it alters physical boundary conditions, the energy intensity, and the exact measurement timeline. In a Bell test, two spatially separated detection events are only counted as a valid pair if their timestamps fall within a microscopic coincidence window, often just a few nanoseconds wide. We must combine this rigid coincidence requirement with the time walk effect generated by the polarizer. Looking at this timeline, the local polarizer angle directly shifts the measurement's timestamp, determining whether an event slides into or slips out of the coincidence window. Consequently, the window acts as a setting-dependent filter, physically selecting a different data subset for each setting. This clarifies the physical meaning of a zero outcome. A missing click is a heterogeneous event. It means field intensity was too low, spatial overlap was poor, or the detector was recovering. It is not simply a missed particle. The Justina data legitimately violates Bell's inequality. But it does so because local optoelectronic filtering dictates the timestamps, directly violating mathematical measurement independence. Local realism remains entirely intact. The reported efficiency of these quantum detectors is a theory-laden inference. It is calculated based on a flawed particle ontology, not the actual behavior of continuous waves. To correct physics, we must respect the epistemic ladder, a hierarchy tracking our distance from absolute physical reality at the bottom up through increasing layers of mathematical abstraction. 20th century physics incorrectly cemented concepts like Wigner's group theory to the bottom rung of ground truth. One-field theory restores the correct hierarchy. The physical medium, the polarisable vacuum, sits at ground truth. Mathematical symmetries are moved up as descriptive maps. Bell's theorem did not fail because the universe is spooky. It failed because the continuous, threshold-based reality of nature cannot be restricted by naive, discrete mathematics. Acknowledging the polarisable vacuum provides the mechanical bridge to unify relativistic causality with quantum phenomena. We replace fractured theories with a single, deterministic electromagnetic field. This approach honors the scientific inquiry demanded by the founders of modern physics. It demands physical explanations and mechanical reality, rather than empty mathematical elegance. The universe is not an abstract mathematical paradox waiting to be calculated. It is a single, deterministic physical field waiting to be understood.